Hi and welcome to our explicit teaching video for solving length and area problems with Mr. Fisk. Now this is a follow-on exercise from our last slide, which was calculate perimeter area, so please make sure you've watched this explicit teaching video before you jumped into this one. Before we get started on our Microsoft whiteboard and our learning intention, got a quick little joke for you. What did the mean triangle say to the circle? You're pointless. I'll let that sink in and see how you go with it. Anyway, let's have a look at our learning intention. I'm learning to calculate the area and perimeter of rectangles and triangles. The basic idea is I can determine the difference between perimeter and area. I can calculate the area and perimeter of triangles and rectangles using a formula, and we can use correct units when measuring perimeter. So that's units and area, which is square units, all right, or they might use squared units. I probably need to put a little d in that one there for us. I might even do that as we speak. Okay, so we are squared units. All right, so that's what we're aiming to do. All right, let's have a look at number one here. Now, number one is broken up, is our understanding. So we're going to have a look at some of this here and understand what's going on. So we're going to use the grid to calculate the perimeter and the area of the following shapes. All right, now let's go back over here. When working out the perimeter, the distance around the outside of the shape. So we're going to have a look at this and work out that. So I might try to zoom in a little bit so we can see that one there. So we're going to be having a look at some regular shapes, which is this one here, some irregular shapes, which we're left with here. Okay, so I'm going to go across and show you a little bit of that. All right, not with the one that you need to work on, but the ones that is over here. So what I'm going to be looking at here is first the perimeter. So the way I work out the perimeter, I'm going to work out the outside. So we've got 3, and I'm going to use the unit of measurement of centimeters because I believe this is what the shape it is, so what the distance would be here. All right, this is also 3 centimeters. Along here is 4 centimeters, 2 centimeters, 1, 2, 3, 4, 5, 6, 7. I should know that because we've got 4 and 3 here, so it's 7 centimeters. And along here we've got 2 centimeters and 3 centimeters, so this one should be 5 centimeters all up, and I'll just double check that. So our perimeter is, okay, and if we come back across over here, our perimeter, all right, is the distance around the outside of the shape. So what normally happens is that you work out the sum of all sides. Okay, so we're going to work that one out for us. Okay, so the sum of all sides. Now I'm going to put this one and this one together, so that's our 5 centimeters. Then I've got this 5 centimeters over here. All right, so I add that one together. Okay, then I've got 4 and 3, which is 7 centimeters. And then I've got the 7 centimeters again, so I'm going to add that one in together. All right, then I can add my 7 and 7, which gives me 14, plus the 10. All right, as I put those together, that gives us 24 centimeters for the perimeter. All right, so that's what we have with that one. Let's work out our area with this one here. Now we've got the measurements, we can go back to our little algorithm, okay, which is, all right, our length multiplied by its width. Okay, that's what we're going to be looking at here. So that's our that is our formula for that one. And again, we come back to our learning intention. All right, that is us knowing the formula for that one. So let's have a little bit of a look into this one here. All right, so here's our area. All right, length multiplied by width. But obviously our length multiplied by width with an irregular shape is a little bit harder. All right, so what I'm actually going to do is I'm going to break this into 2 shapes. So I'm going to use a different color here. So I'm going to work out this one first, which is going to be 4 multiplied by, all right, 2. All right, so 4 centimeters multiplied by 2, which will give us our 8 centimeters squared. All right, so I'm going to put that in there. All right, then I'll go a different color here, and I'm going to look at this last little shape, which is 3 multiplied by 5, because that is what, all right, we are working with. And obviously that's centimeters. All right, for both of those. So 3 centimeters multiplied by 4 centimeters, all right, equals, all right, 12 centimeters squared. The reason it's squared is because there's technically, all right, 12 of these squares in there. All right, so now I'll put them all together in our area. We do 12 centimeters squared plus, and I'll do that in black, I reckon, plus, all right, 8 centimeters squared equals, all right, our 20 centimeters squared. So that's how we end up working out your area and, all right, our perimeter for those shapes using the grid. Okay, and obviously had a irregular shape there, so you'll be able to work through your way through that one there. Now, fluency has been able to work out the shapes that we have here. So ideally, you should know how to calculate the square and rectangle shapes here. All right, if you access your length multiplied by width, all right, which is what we just did before. Okay, so that's our length multiplied by our width, and that's our area, and that's going to equal centimeters squared. I'm assuming, depending, actually they're all meters there, I'll apologise for that. Alright, the units that you're using is meters squared, because you're actually going to be working out the meters squared in the answers of those ones. But here, alright, we're going to be working out triangles, and that's a new concept for you, so I'm going to take you over, alright, to this little one here. So the area of a triangle is half the area of a rectangle, and the reason is, okay, alright, is that you notice with this picture is that a triangle is half of a square or a rectangle. So let's use this one for example here. Alright, I might just move it down just a little bit. Alright, let's work out, let's say this is 10 centimeters by 5 centimeters. Nice and simple, probably not to scale, but close enough. Let's work out the area of this one. So that would be 5 centimeters multiplied by, oops, no, that's the answer, multiplied by 10 centimeters, which will equal, alright, let's make sure I put my multiplication sign in there, that would help out a little bit, wouldn't it? Alright, our multiplication sign, alright, that would be 5 multiplied by 10, which will give us 50 centimeters squared. Now we're working with a triangle. Now the triangle formula is half base times height, oops, alright, by height. Okay, and the reason that is because a rectangle is half. Alright, so let's have a look at this now. I won't be able to do this perfectly, but if I put a line through this one, you can see that a rectangle when it's cut diagonally in half, it gives you, alright, half a rectangle. So that's why when you're working out a formula of a triangle, alright, that is why it's half base times height. So let's have a look at this one here. So if I actually get rid of this line and we just look at it, okay, as a triangle, alright, so we've got now rubbing this one out, okay, alright, we now, and I'll get rid of this one here because I'll come down a bit further, we now have 5 centimeters and 10 centimeters here, because ideally this part of the shape is actually gone. Okay, so we're only working with this half, alright, and we do, alright, we'll have a look at our formula, which is half multiplied by the base, half multiplied by base times height. The height here is 5 centimeters, okay, the base is 10 centimeters, alright, and it's half, so I'm going to actually work that one out. So 10 multiplied by 5, which is 50 centimeters squared, alright, and I'm also going to half that, and we know that half of that, or divide that by 2, is going to equal 25 centimeters squared. So that is how you work those ones out, but ideally they're not always perfect, okay, when it comes to your triangle. Obviously over here we can see that that is half, alright, oops, you can see that that is half, but they're not always the case. There's sometimes, alright, a triangle looks like this, and if I remember correctly, this is an isosceles triangle where each side is the same. Alright, we're going to have a little bit of a look at this one here. Alright, so the reason this would also be, let's say that this is about 6 centimeters high, alright, and okay, and we've got 5 centimeters along here. I'll get rid of the stuff that's below it, okay, just so that it doesn't become a bit of confusion. The same concept applies. It is still going to be, alright, it is still going to be half base times height, okay, alright, so let's have a look at what will happen here. Alright, so the height is 6 centimeters and the base is 5, so we're still going to do half 5 multiplied by 6 centimeters. Alright, and that will actually give us 30 centimeters, but it's half, and we're going to make it 15 centimeters squared. Alright, that would actually be the answer, and the reason is if I get the blue here, it's still half a square. And I'll draw that up. Now I know it's not the scale, but you get a bit of an idea of how that might look. Okay, now the last one of our problem solving here, which is the next section, it says the rectangle below has a perimeter of 14 centimeters and it has an area of 12 centimeters squared. Can you draw 2 more rectangles with the same perimeter but each with different perimeters? Okay, so we're going to be looking for a 14 centimeters. So I'm going to do this one here and see if it helps out. So I'm going to look for 14 centimeters. So I'm going to draw this one here. I'm going to start, well, I can't do 7 centimeters because if I do 7 centimeters, it'll be 1 here, it'll be 0, it'll be a line. So I'm going to start with 6 centimeters here. I'm going to come across 1 centimeter. And then I'm going to come back down. And then each of that sides, well, look at that. That's pretty impressive. All right, it's going to be that way. And if I add up my perimeter, all right, it'll equal 1, 7, and 14 centimeters. Okay, now I'm going to have a look at my area. I'm going to do the same thing here, but I'm going to do my length multiplied by width. 6 centimeters multiplied by 1 centimeter, and it's going to equal, obviously, our 6 centimeters squared. Okay, now obviously giving you guys a bit of a shape there, but I reckon, all right, I reckon you might be able to have a little bit of a play around with it and see what else you can come up with. Okay, so that's that one there. And the last little bit of the worksheet is pretty straightforward. Okay, it says, in words describe how you find the area of a rectangle or square. In words describe how you can find the area of a triangle. I believe that I've done enough of that for us to work that, for you to write that in your own words. Okay, so you can always listen back over the video for that to happen. Let's go back over this here. Our learning intention is I'm learning to calculate the area and perimeter of the rectangles and triangles. Oh, looks like I've got a little extra E in here. I might have to get rid of that. Apologies about that one. Alright, this is our criteria is we're going to determine the difference between perimeter and area. Okay, we had a little bit of a look at that on a previous video. Alright, but we did have a look at this little chart here. Okay, we know the perimeter is the outside, alright, while the area is the number of square units on the inside. Let's go back over here. We can use the formulas for us to be able to do that, so we know where the formulas are. Alright, I already had a tick there from last time. Alright, so let's have a look at, okay, a couple here. We know that working out the area of a rectangle or a square is length multiplied by width. Okay, we saw that over here, we looked at that before, and then we worked out that, okay, working out the area of a triangle was half base multiplied by height. Okay, so we know that. And the last one was, okay, we know and use the correct units of, alright, measuring perimeter, which we use units, which we can see that we've done here, alright, and we've also done here. Alright, making sure that we're using our centimetres squared or units squared for area and using our units just for perimeter. Apart from that, that is solving length and area problems. I really hope you enjoyed my video. Alright, I'm hoping it's recorded. That's one thing I got to double check, and see you later.